Today's lecture, we will discuss the concept of multicollinearity. Here you can see that with the help of a Venn diagram, in the first we have y dv means dependent variable, while we have two independent variables x2 and x3. With the help of this Venn diagram, you can observe that there is no relationship. On the other hand, you can see that in second Venn diagram, there is a low relationship between IVs. While looking at third diagram, you can observe that there is some moderate correlation. And in this fifth diagram, we can easily observe that there is a high collinearity. On the other hand, like in last diagram, we can observe that there is very high collinearity. So this problem occurs when the explanatory variables are very highly correlated with each other. Now, according to our classical linear regression model, there not be exact relationships amongst these explanatory variables. So the problem of multicollinearity is found amongst those explanatory variables when those variables are highly correlated with each other. Now, there are two cases of multicollinearity. The one is perfect multicollinearity, and the other one is imperfect multicollinearity. Now, in case of perfect multicollinearity, uh, even with the help of software, we cannot get beta's values as well as the output of a regression model. Now, here, for example, we have two IVs and one DV, X1 and X2 are two IVs. Looking at these two series, it seems to be different, but it can be observed that there are two explanatory variables. In fact, it is only one variable, that is X1, and the exact linear function of x2, as basically you can observe that x2 is basically multiplied by x1 is multiplied by 2, or it is multiple of 2. Uh, in that case, even you will not get any output while running in different software like eViews, SPSS, and so on. Now, the second case is imperfect multicollinearity. Now, in imperfect multicollinearity or near multicollinearity, we have again two series, and the second series is basically multiple of first series plus any other values like 6 twos are 12, added we add 3, it becomes 15, and so on. So in classical linear regression model, we will have to take care of these irregularities, the means multicollinearity. Now, how we can detect multicollinearity? So there are different methods to detect multicollinearity. Like the first one is a simple correlation coefficient. Get correlation coefficients amongst different IVs. If there is a high R, say 0.8 or greater, so it may be the case of multicollinearity. Second, if we get high R square and then our betas or coefficients are insignificant, then it may be the case of multicollinearity. With the help of variance inflating factor VIF, we can also observe whether there is multicollinearity or not. If we have higher the R square will lead to higher VIF, that indicates that higher degree of multicollinearity. This is a formula that how we can get VIF is equal to 1 divided by 1 minus R square. And then we have another measure that is called tolerance level. Now, according to this measure, 1 divided by VF, and when multicollinearity is higher, and then this tolerance level would be smaller. And the VIF values, we have the table like this one. Uh, if we have 10 or greater VIF, then it would be the case of multicollinearity. Now, in case of multicollinearity, what would be the consequences Now, here are some consequences that estimates of the OLS model may be inaccurate due to large standard errors. Means we will get large standard errors. As a result, there are chances that the significant variables becomes insignificant. So as a result, coefficients are affected that will lead to insignificant result because of low t statistic. Second, we can get sign reversal. For example, theory suggests that there is a positive relationship between one of IV and with DV, and maybe we will get a negative sign. If theory suggests positive signs, or if theory suggests negative sign, and we will get, let's say, positive sign, then there would be the case of multicollinearity. Then the estimated coefficients get substantial changes when we add or delete few observations in the data. For example, we have 100 observation, and if we add 2 or 3 or maybe 5 observation, or we will delete 2 or 3 or 5 observation, we will get some different results. As we know that we can also check the basically hypothesis testing with the help of confidence interval as well. So our confidence interval parameters also become widened, and this maybe can give us inappropriate conclusion that it will lead towards rejection of alternate hypothesis. Means we cannot accept our alternate hypothesis. So these are basically the consequences. So we will definitely take care of all these consequences, and we will have to solve these consequences. So what may be the solution? Here are some solutions that are recommended, and that traditional approaches such as regression or principal component analysis can be used, but usually econometration suggests that these usually bring more problems than they solve. Some econometrations are good that if model is otherwise okay, just ignore it. Mean you can go with the multicollinearity as well, but it is the suggestion of some combination. We should definitely we can take care of it. Now, the easiest way to clear the problem is that we will have to drop one of the explanatory variables that is very much collinear with other explanatory variables. The second thing that we can transform the highly correlated variables into a ratio as well. Uh, Third, we can go out and collect some more data, like a longer run of data, or we can switch to high frequency, like if the data is based on annual basis, we can switch to semi-annual or quarterly, annual, monthly. So this is about the main concepts of multicollinearity. In the second part of this video, we will take the data and we will observe that what is the case of no multicollinearity, imperfect multicollinearity, perfect multicollinearity, and how we can detect with the help of auxiliary regression as well. So this is about the main concept of this multicollinearity. In the next video, we will basically, with the help of data, we'll discuss different issues that is related to multicollinearity.